All right. So the protein that I was assigned is the type 1 collagen and is a negative and it mutation is a dominant negative substitution of glycine for a larger amino acid in several locations. As you can see, here is my unmutated protein, and here's my mutated protein. You have differences between the two, as you can see, is the larger amino acid is substituted for the glycine along here, along this row, and this causes many different types of mutations and alters and all these different types of things. So let's look into it. The normal function of this protein is to provide flexibility and stability. The protein tends to hold structural function. The reason I chose this category is because it's very interesting. I also wanted to know more about this topic. So, where is this protein found at? This protein is typically and normally found in connective tissues such as bones, cartilage, or any type of ligaments inside your body. They are also found in fibrils, which fibrils consist of many collagen, and most of the collagen in these fibrils come from fibroblasts. The collagen can be found in dogs, humans, cats, or any other type of organism that have structural features with bones, such as bones, ligaments, as stated before. So, how does this mutation affect me? So the mutation has many changes on the protein functions. The protein no longer has the tight bonds because of the glycine, and also because the glycine has been replaced by these larger amino acids right here. And also, patients with this disease who develop this disease are lacking collagen, and so their bones are a whole lot brittle and more fragile, and they're more prone to breaking. So the name of the disease from this mutation is called osteogenesis imperfecta, and also known as a more simpler term, the brittle bone disease. So after the mutation, the protein is either hydrolyzed by the cell or fails to function properly just in general. Like the whole cell just stops to function properly and no longer functions how it did before. So the structure is less stable when it gains this amino acids. The structure itself is less stable. So the abnormal helix structures that is caused by the mutated functions of these different type of amino acids inside here cause the ability to just in general destroy the host protein and messes up just the general structure of the protein. So the main functional groups present in the original amino acid chain or the protein are the hydroxyl groups. You have your amino, and you also have your bicarbonyl groups. And these consist of, right here for the unmutated protein, you have your proline, your hydroxylene, and then you also have your glycine. So the original side of the chain for the original protein, the unmutated version of the protein, is hydrophobic. The AA side is large compared to others. So glycine's hydrophobic side chains it just stops it from coming in contact with water. Hydrophobic meaning that it is not like water and repels water. It also is nonpolar. So this unmutated protein is nonpolar. Collagen is hydrophobic, even though there are some hydrophilic faces on the protein. Glycine is also one of the simplest amino acids with its chain consisting of hydrogen. So when you do have this glycine in here, right here, and not have that amino chain in there, just the glycine, the bonds do become tighter, and all the bonds between them are more stronger than with this amino acid, because this is very large and it does not work properly throughout the cell. The mutated AA side chain are hydrophilic and attract water. They have multiple negative charges, which causes their molecules to repel each other. So hydrophilic meaning that it does like water, it's water friendly. So the differences in the type of bonds that AA side chain can participate in compared to the original AA side chain is that the mutated bond can participate in bonds with water. So hydrophilic bonds and all those type of different bonds that can include water inside them because it is hydrophilic. So a question that may be asked, how does the mutation affect the protein function, the function of the cell, and also the organism function? So the protein is no longer able, when you have this when you have this mutation in this cell compared to this one, the protein is no longer able to form these tight bonds because of the substitute of the larger amino acid for the glycine, and the cell does become less active, and organisms becomes deformed, and the physical features in general are altered. So just as we stated, if you look at some pictures of osteogenesis imperfecta, as you can see that there are some deformities in the person. So, last but not least, there were various limitations in my model. So some limitations, one main limitation that I had is the complexity of the protein. And since my protein was so complex, it was hard. It's typically hard to be able to depict this on a model, but you can have a smaller representation of it, but you don't have all of it. Another one is the size. The protein is kind of large, and so you can't really put all of that on a model, but you can display what is needed. And one other one is the various different smaller details, like the very fine print of the protein can't be really included in the model, but you have to depict what I have. So that's 3 of my top limitations or anything that was kind of hard through this project. Thank you.